It's beautiful, it's poetic, it's romantic, but overall, it's science. I don't want to break the spell over sunsets, but have you ever asked yourself why the sunsets have these beautiful colors? I'm going to give you a quick explanation of a light phenomenon called scattering and why it happens on our planet's sunsets. But first, let's learn a few things about the electromagnetic spectrum and wavelengths. Light moves in waves, such as the ones in the ocean or a lake, but they move through the air in a form of energy called electromagnetic energy. Electromagnetic energy has several parts. All of these parts form the electromagnetic spectrum. And since they move in waves, each has different wavelengths. What's a wavelength? A wavelength is the distance from the top of a wave to the top of the other wave, or from the bottom of one to the bottom of the next one. From the bigger wavelength to the smaller, we have several wavelengths. We have radio waves, microwaves, like the ones on the microwave oven. We have infrared, which means below red. We have the visible light, which is the one that we're talking about. Then we have the ultraviolet, which means above violet. We have X-rays and gamma rays. Each wavelength is associated with a specific frequency and level of energy. The smaller the wavelength is, the higher the frequency and level of energy it has. The bigger the wavelength, the lower the frequency and level of energy. Now that we understand the electromagnetic spectrum, let's focus on the part of visible light, which is so special to us because we can see it. As part of the electromagnetic spectrum, light has the same characteristics, so light can be divided in several wavelengths. Light, it's not just white, it contains every color in the visible spectrum, like the rainbow. There are many other colors that we cannot see, such as the infrared and ultraviolet. Bees can see ultraviolet colors, for example. Within the visible light, each color has its own waves, and thus, each color has its particular wavelength. Red light waves have wavelengths around 700 nanometers, while blue and purple light have even shorter waves with wavelengths around 400 or 500 nanometers. A nanometer is 1/billionth of a meter. A human hair, for example, is around 60,000 and 100,000 nanometers wide, so you can picture the size of color waves. Another characteristic of light is that when it passes from one material to another material with a different density, it changes course. And because colors have different wavelengths, they bend by slightly different amounts. When blue light passes from air through a dense glass prism, for example, it bends slightly more than the red light does. So, what causes this scattering of the light in our sky? Well, our planet Earth has an atmosphere around it. This atmosphere contains oxygen, water vapor, nitrogen, and argon. All these gases act as the prism, so when the sunlight, which is traveling through the vacuum of space, enters our atmosphere, which is denser, the light scatters. During most of the day, the scattering is not so noticeable, but during the sunrises and sunsets, where there is a lot more of atmosphere for the light to travel through, because of the angle of the sunlight impacting the place where we're standing on, we see the longer wavelengths, such as the red and orange, which scatter much less than the shorter blue ones. At that moment, the blue wavelengths scatter out of our sight, and because red has the longest wavelength of any visible light, the sun is red when it's on the horizon, where it has a long path to go through and the atmosphere blocks all other colors. So the next time you're watching a sunset with your friends, family, or maybe with your loved one, enjoy how beautiful, poetic, and romantic it is. But also enjoy the fact that you now know which wavelength in the visible light spectrum your eye is capturing, the red one, and that it happens because of our planet's atmosphere acting like a prism on the sunlight, scattering blue wavelengths away from our vision.